Hello, my name is Gregoria Ramirez. Today I will be showing my code review for the CS499 Capstone project at SNHU. My project I am working on is from a project I did in February 2025. The artifact that I selected is from my CS340 course where I developed an animal shelter dashboard using Python, Mongo database, and Dash. I selected this artifact because it allows me to demonstrate my computer science skills in all three required categories, which are software design and engineering, algorithms and data structures, and databases. I will be using this one project for all three enhancements. In this code review, I will walk through my original code that I created in Jupyter Notebook. I will explain my code and its functionality and explain the areas in which I plan to improve. My original animal shelter dashboard was created in a Jupyter Notebook environment using CSV files for data and Mongo database shell commands for querying the database. The main goal was to support CRUD operations, which are create, read, update, and delete. The dashboard allowed users to search and filter, such by animal records, by type, age, and sex, and display data from animal rescue shelter using Dash components with charts, tables, and maps. The original code was limited. It only filtered by rescue type and used manual database queries typed into the shell. There were no separation of logic for separating the database operations from the display code, and the credentials were hard-coded, which is not secure. To enhance this project, I migrated the code to Virtual Studio, imported the CSV file into Mongo Database Compass, refactored the code into separate folders and files, and added filtering by breed and color. I also created a reusable CRUD class and used secure practices to store credentials. For my enhancement plan summary, I will focus on three areas that I will improve on. The first one is going to be the software design and engineering. I will be refactoring monolithic code into modular structure, remove hard-coded credentials for added secured handling, and integrate logging and use Mongo Database Compass for clarity. For algorithms and data structures, I will improve filter logic for breed and color, refactor inefficient search conditions, add input validation and better error handling. And for databases, I will be replacing hard-coded credentials with secure configuration handling, transitioning from Mongo Shell to Mongo Database Compass, have a centralized all CRUD operations in a reusable class, and explicitly close Mongo database connections after operations. I am going to start my code review, and this is my animal shelter.py from my animal shelter dashboard project from CS340 that I had the course in software development. So this code right here is going to be my import code, and this import tools are what I need for the Mongo database. The Mongo client is what actually connects my Python code to my Mongo database. And I also had imported an object ID, which lets me reference specific Mongo database collection IDs if needed. This code here is my exceptions, which is going to catch any database errors. I custom defined exceptions here for it helps me catch and handle database errors in a cleaner way instead of letting the program crash. Sometimes if it crashes, you get a bunch of stuff that you don't even know what it means. This section right here is the animal shelter class, where it manages everything that I need to interact with the animals collections, which includes my create, read, and update and delete operations. The next section here is my constructor using the de-under-init method. This will define the settings for my Mongo database connection, and then I use the settings to connect to the database using the Mongo client. So this top part up here is the credentials, and as you can see, these are hard coded. So this is one of my plans of my enhancement is to change this. So it has the user, password, host, the port that it was working on from the database name, and the collection. And the second part here is what connects it to make it function in the database. So for this whole section here, my enhancement plan for software design and engineering, I will replace hard-coded credentials with environmental variables for better security. I will also modularize the configuration into separate settings file and store credentials in an environment file. And for the databases part, I will migrate from using the Jupyter Notebook and Mongo Shell and use Virtual Studio Code and Mongo Database Compass for managing and importing the CSV data. This will make the project more professional, easier to maintain, and improve visibility and control of the database. The next section here, I'm defining my closed connection, and this method simply closes the Mongo database connection when I'm finished, and it just helps keep things safe and confirms that the connection will be closed. For my enhancement for software engineering, this is one of the things that I will replace the print statement logging and ensure this method is called automatically as part of a cleanup process. This supports safe resource management and better structure. The next section here is my create. And this create method adds new documents in the collection, and in this instance it's going to create one. It first checks that the input is a valid dictionary, then it will insert it. If the insert works, then it will return true. If not, then you will get the error. It will catch the error. The next part here is the read. And the read method returns documents from the database that matches a query. If no query is passed, it shows everything. I also converted the ID field here to a string so it's easier to work with. And for my enhancement plan for the database, I will improve the exception handling and validate all inputs before querying. I would also add logging to track the number of documents returned for debugging purposes. The next section here is the update method, which is used to change existing records. I gave it a query to match the new data right here. So update by many, update by one. It will flag it if it doesn't have the correct dictionaries, and it will return how many documents that were there. My enhancement plan for databases for this is to add better validation, structured error logging, and modularize this method into a shared update utility to improve clarity so it can be reused. My next section is for the delete. And the delete method removes one or more documents from the collection. It uses a query and a multiple flag. Then it returns how many documents were deleted. If there's an error, it will catch it and it will let you know. It also tells you the number of documents that were deleted. So for this enhancement for database, I will validate input fields and convert the logic into a reusable delete module. And I will also use structured logs for traceability. The next section here is my validate field. So before I try to filter anything, I will use this method to check if the field exists in the database. If not, it's going to return an error. So again, for my enhancement plan for databases, I will add a fallback logic for when the collection is empty and include logging to flag when validation fails due to missing fields. My next section here is going to be my filter by rescue type, which would be like the water rescue or transfer options that they have in the database there. This will return animals based on their rescue type and make sure that the field exists and input is valid. Then it will query the database. My enhancement plan for algorithms and data structures is I will combine this with other filters in one dynamic method to reduce the code duplication and improve flexibility. The next code here is for filtering by breed, such as Labrador or short-haired mix cat, for instance. This filters the animals by the breed, and it uses a regular expression to allow for partial matches in case insensitive matches, such as lowercase or uppercase letters. This section here is going to be filter by rescue and breed, and this one will filter for both the type and the breed, and it verifies both inputs and runs a combined query. And again, if there's an exception here, the error will let you know. It will let you know if it's not a string. So my enhancement plan for algorithms and data structures is I will merge this into a filter method and enhance to handle multiple fields and support flexible matching. And this part here is the multiple fields, which it's going to create a dynamic query using multiple filters and uses regular expressions for partial and case insensitive matches. And for my enhancement plan for algorithms and data structures, this method will be used for the foundation for future filtering. So I will improve its validation, input handling, and the documentation. And this was just part of the code here, which checks for the case insensitive words. So this was my code review, and what I showed in this code was before I had hard-coded database credentials. I had the entire project in one Jupyter notebook, no logging or modular designs. I had repetitive and limited filtering logic, no input validation. Mongo Shell was used for the queries, and the database connection was left open. So what I will be doing is I will be replacing hard-coded credentials with secure configuration handling, transitioning from Mongo Shell to Mongo Database Compass, added logging system and separate logic into components, expand the filtering with breed and color support, added input to prevent invalid queries, centralize all CRUD operations in a reusable class, and close the Mongo database connections after operations. So again, according to the code review checklist for my software in engineering and designing, I will be replacing hardcode credentials with environmental variables, using an environmental file to store sensitive values, replace all print statements with logging, ensure the close method is used properly, organize code into reusable modules and folders, and this will match with my checklist for modular code, magic numbers removed, secure credentials, and consistent documentation. For my algorithms and data structures, I will combine individual filter methods into one dynamic filtering method. I would add validation for all import fields before querying, use regular expressions for flexible case insensitive filtering, refactor filtering logic to reduce repetition, improve structure and readability of filtering functions, and this will match my code checklist for efficient data handling, loops and logic being structured, and flexible reusable methods that are added. For my databases, I will migrate from Jupyter Notebook to Virtual Studio Code, migrate from Mongo Shell to Mongo Database Compass, improve error handling for create, read, update, and delete operations, add structured logging for database actions, validate input before performing database operations, ensure Mongo database connections are closed properly, and this will match my code checklist for assigning output variables, validate my queries, adding error handling, and closing my connection properly. And this is my code review for my CS499 Capstone project at SNHU.